This section is on right triangles, and more specifically how to use the Pythagorean theorem when you have right triangles. The Pythagorean theorem is a squared plus b squared equals c squared. It will help you to look at the diagram on the left. Notice that two sides are marked a equals 3 and b equals 4, and those are the shorter sides of the triangle. Those are called legs, and they're by convention given the letters a and b. The longer side, c, is the hypotenuse. Here is a very simple Pythagorean theorem problem to get you started. Given that a equals 3 and b equals 4, find c. We substitute into the Pythagorean theorem. Recall that a squared plus b squared equals c squared. We replace a with 3 because we're told that's what a equals in this problem, and we square it. We replace b with 4 because we're told b equals 4, and we square it. That equals c squared. 3 squared is 9. 4 squared is 16. 9 plus 16 equals 25, and that equals c squared. Recall, however, that we are not solving for c squared, we're solving for c. Therefore, we take the square root of both sides. The square root of 25 is 5, and the square root of c squared is c. Just as a caution, when you're dealing with ordinary algebra equations and we take the square root, we would have to consider both the positive and the negative values. For example, the square root of 25 would be both 5 and negative 5. But in geometry, when we're dealing with lengths and distances, since those quantities can't be negative, we ignore the negative roots. Here's Charlie's ladder problem. Charlie's girlfriend Rhonda is grounded until she improves her algebra grades. Charlie wants to take her to the movies. In order to do that, he must sneak her out of her second-story bedroom. The bedroom window is 15 feet above the ground, and the foot of the ladder must be 8 feet away from the base of the house for safety reasons. How long must Charlie's ladder be? And here is an illustration of Charlie's ladder problem. Right? If we look at the solution, we see that a squared plus b squared equals c squared. The distance from the base of the ladder to the house is 8, and we're replacing a with 8 and we're squaring it. The distance from the ground to Rhonda's bedroom window is 15, and we're squaring that. And we have a right angle because presumably the house is straight up and down and the ground is straight across, and that forms a right angle. In any case, 8 squared plus 15 squared is 64 plus 225. That adds to 289, and it's equal to c squared. Taking the square root of both sides gives us 17 equals c. Therefore, his ladder must be 17 feet long for him to safely get Rhonda out of the house and to the movies. Here's another example. In the previous problems we've done, we've been given 2 legs and we were asked to find the hypotenuse. This is a little different because we are given 1 leg and the hypotenuse, and we're asked to find the other leg. Again, we use the Pythagorean theorem, a squared plus b squared equals c squared. We're told that one of the legs is 12, and that's from the diagram. We replace b with 12 and we square it. We're told from the diagram that the hypotenuse is 13. We replace c with 13 and we square it. This gives us a squared plus 144 equals 169. We're trying to get a by itself. We begin by subtracting 144 from both sides. This gives us a squared equals 25. Taking the square root of both sides gives us a equals 5. Here's an example in which we use the Pythagorean theorem twice. We're told that ABCD is a rectangle and that CE is congruent to BE, and we're asked to find the length of BC. And I'm giving you a hint. Find the length of CE first. Because we have a rectangle, we know we have a right angle at D by definition. 3 and 5 are the legs of a right triangle. We substitute into the Pythagorean theorem to find the hypotenuse CE. When we do that, we have 3 squared plus 5 squared equals CE squared. That gives us 9 plus 25 equals 34. Therefore, CE equals the square root of 34. And we also know that BE will equal the square root of 34 because those two legs are congruent, and that's a fact given to us in the problem. Now what we're trying to do is find the hypotenuse of triangle CEB. The hypotenuse is CB. To find CB, we substitute into the Pythagorean theorem. The square root of 34 squared plus the square root of 34 squared equals the hypotenuse, which is CB squared. This gives us 34 plus 34 equals CB squared. Recall that when you square something under a radical, or put it another way, you multiply a radical term by itself, the hood comes off, so to speak, and you're left with what's under the radical. So when we square the square root of 34, we get 34. 34 plus 34 equals 68. 68 equals CB squared. To find CB, we take the square root of both sides. We can simplify that. The square root of 68 equals the square root of 4 times the square root of 17. The square root of 4 equals 2. The square root of 17 does not simplify, hence we're left with 2 square root of 17. Here's a sample problem in which you are asked to use the Pythagorean theorem, but instead of being given the lengths of the legs outright, you are asked to find them by reading a diagram. Look at AB. The y-coordinates of A and B are the same, and we can ignore them because it's a horizontal line. But look at the x-coordinate of A. It's -1, and the x-coordinate of B is 2. To find that distance, we can subtract 2 minus -1 is 3. Hence, AB has a length of 3. Now look at segment AC. Here, the x-coordinates are the same, and we can ignore them, and we just need to look at the y's. The y-coordinate of A is 3, and the y-coordinate of C is -1. We subtract to find the distance. 3 minus -1 is 4. Hence, we have two legs of 3 and 4, and we know by substituting into the Pythagorean theorem that the hypotenuse will be 5. That's not a tremendously difficult problem, but you do need practice in reading graphs and diagrams. Here are some practice problems for you to try. Pause the DVD after each problem. When you have finished, come back for the answer. In problem 1, find the length of the hypotenuse. And again, find the lengths of the legs by analyzing the diagram. The answer to problem 1 is 10. The trick is in reading the diagram. If we look at the horizontal line segment AB, the y-coordinates will be the same and we can ignore them. The x-coordinate of A is at -4, the x-coordinate of B is at 2, and 2 minus -4 is 6, and that's the length of the line segment AB. Now look at the vertical segment BC. The x-coordinates of B and C are the same, and we can ignore them, but look at the y-coordinates. The y-coordinate of B is at -2, the y-coordinate of C is at 6. The distance between 6 and -2 is 8. Therefore, we have two legs, one with a length of 6, the other with a length of 8. Substituting into the Pythagorean theorem gives us 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. 100 equals c squared. Taking the square root of both sides gives us 10 equals c, which is the length of the hypotenuse. Here's practice problem 2. Given the trapezoid below, find the length of CE. And here's the answer to practice problem 2. It's 24. Your first step is to find the hypotenuse of the triangle ABC. It's the triangle on the left. We're told that the legs are 6 and 8. If you remember the last problem, you will know that BC, which is the hypotenuse, must be 10. We now know two sides of right triangle BCE. One side is 10, that's a leg, and then the hypotenuse is 26. We substitute into the Pythagorean theorem. 10 squared plus b squared equals 26 squared. 100 plus b squared equals 676. Subtracting 100 from both sides gives b squared equals 576. Taking the square root of both sides gives us b equals 24. Here's practice problem 3. Given the trapezoid below, find the length of AE. The answer is 12. First, find the hypotenuse of triangle BCE. Since the legs are 3 and 4, the hypotenuse must be 5. Now find the leg of the triangle when the hypotenuse is 13. Again, we're working with triangle ABE now. And we know that one leg is 5 and the hypotenuse is 13. We substitute into the Pythagorean theorem, and we get 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. We subtract 25 from both sides. This gives us b squared equals 144. Taking the square root of both sides gives us b equals 12. Here is the answer to practice problem 3. The answer is 12. Your first step is to find the hypotenuse of triangle BCE. Remember, the hypotenuse is the line segment BE. Since the legs are 3 and 4, we know from our previous work that BE must have a length of 5. Now let's work with triangle BEA, which is the triangle in the center of the figure. And the little corner drawn in at point E tells us that it's a right triangle. We substitute into the Pythagorean theorem formula. This gives us 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. Subtracting 25 from both sides produces the result b squared equals 144. Taking the square root of both sides gives us b equals 12. Here's another Charlie problem. Charlie's mom is really mad at him and chases him around the corner of the house. When he is 8 feet from the corner on one side and she is 15 feet from the corner on the other side, how far apart are they? What we need to realize is that the corner forms a right angle, and we have a right triangle with the sides of the corner, and then the hypotenuse would be the line directly from Charlie's position to his mother's position. Now all we do is substitute into the Pythagorean theorem. 8 squared plus 15 squared equals c squared. 64 plus 225 equals c squared. 289 equals c squared. Taking the square root of both sides gives us 17 equals c. Given a circle of radius 5, find the length of BC. Hint: how do you know the triangle is a right triangle? The answer to problem 5 is 5 square root of 2. We know this is a right triangle because 2 of the legs are radii of a circle. They must be congruent, and their base angles must be congruent because they form an isosceles triangle. Therefore, if angle B is 45, angle C is also 45. Because the angles of a triangle always add to 180, the only possible value for angle A is 90 degrees. Because we know we have a right triangle, we substitute into the Pythagorean theorem formula. A squared plus b squared equals c squared. Both a and b are equal to 5. Hence we have 5 squared plus 5 squared equals c squared. 25 plus 25 equals c squared. 50 equals c squared. Taking the square root of both sides tells us that c equals the square root of 50. The square root of 50 can be simplified. And recall, we're looking for the largest perfect square that divides evenly into 50. That is 25. Hence, the square root of 50 becomes the square root of 25 times the square root of 2. The square root of 25 equals 5 times the square root of 2. Problem 6. If a square has a diagonal of length 6, what is the length of its side? You may recognize this as a 45-45-90 triangle, and you could just divide by the square root of 2 and rationalize and get 3 square root of 2. Assuming, however, that you didn't recall that or didn't recognize that, remember, since we're talking about a square, the two legs are equal and the diagonal is the hypotenuse. Let's call the two legs x. We replace a and b with x and we square them. We get 2x squared equals 36. Dividing by 2 on both sides gives x squared equals 18. Taking the square root of both sides gives x equals the square root of 18. We simplify. The largest perfect square that divides evenly into 18 is 9. Therefore, the square root of 18 becomes the square root of 9 times the square root of 2, which is 3 square root of 2. Problem 7. A car travels due north for 12 miles as another car travels due east for 16 miles. How far apart are the two cars? We need to recognize that if one person or object is traveling north and the other is traveling east, that forms a right angle, and the distance between them is the hypotenuse to a right triangle. Therefore, we substitute into the Pythagorean theorem. 12 squared plus 16 squared equals c squared. 144 plus 256 equals c squared. That adds to 400. We have 400 equals c squared. Taking the square root of both sides gives us 20 equals c. Here's problem 8, and it's a bit challenging. A girl is flying a kite. Her hand, which is holding the kite string, is 5 feet above the ground. The kite itself is 15 feet above the ground. The horizontal distance between the girl and a point directly below the kite is 20 feet. What is the length of the string? Examine the diagram carefully before you attempt a solution. Note that the kite is 15 feet above the ground, but only 10 feet above the girl's hand. Also know that the answer is 10 square root of 5, and let's talk about how we got to it. We substituted into the Pythagorean theorem a squared plus b squared equals c squared. Notice that what we're substituting for a is not 15, but 10. And we have 10 squared, and the horizontal distance between the girl and the kite is 20 feet, and we replace b with 20 and we square it. Squaring those numbers gives us 100 plus 400 equals c squared. This adds to 500, and 500 equals c squared. Taking the square root of both sides gives us the square root of 500 equals c. We want to simplify. The largest perfect square that divides evenly into 500 is 100. The square root of 500 equals the square root of 100 times the square root of 5, which is 10 square root of 5.